Hey guys, Pankaj here. Welcome back to my YouTube channel. So here is another video on hackathon series. So today we are going to take another challenge and we are going to solve it step by step. Okay, so let me share my screen. Yeah. Okay, so let me go through the problem first. So those who are watching this video first time, so I would say please go back to previous video where I have recorded I think another 2-3 session on different kind of problem solving. Okay, so in today's video also I'm going to solve another problem which may look very cumbersome or maybe little challenging, but when I solve it then you'll find how easy it is. Okay, so all you need to do is just understand the problem step by step. So let me read the problem first. So here is the problem. Sam's house has an apple tree. This is apple tree and this is orange tree. Okay, an orange tree that yield an abundance of fruit using the information given below. Determine the number of apples and oranges that land on Sam's house in the diagram below. Okay, so let's see the conditions what they mention. The red region denotes the house. So this red region is basically house. Okay, where S is the start point of the house, or maybe another one corner of the house, and T is another corner of the house. Okay, the apple tree is to the left of the house, so that is apple tree which stands in point A. And orange tree is in the right side. Okay, assume the trees are located in the single point, that is point A, where the apple tree is point A and the orange point tree B. Okay, when a fruit falls from its tree, it lands to D units. Okay, so let's say apple is falling from the tree, it will land somewhere, right? So that distance from that particular tree is called D. Okay, similarly, if orange is falling from orange tree and it is landing somewhere, then that point will be called, where is that point? When fruit, yeah, and the D and B is not mentioned. Okay, so anyway, distance will be D basically, either for apple or orange. But distance will be measured. For apple it is measured from A, and for orange it is measured from B. Okay, next one is when a fruit falls from its tree, it lands D units of distance from its tree of origin. So origin from the tree will be obviously where it is located, that is point A and B. Okay, along with the x-axis, a negative value of D means the fruit fell D units to the trees from left. So of course, if it is falling to the left side, means it is talking about orange tree, and if it is falling to the right side, it is talking about apple tree. That's what the assumption you need to make. Okay, based on the distance, because let's say this is x-axis and this is y-axis, right? So from x-axis to the right, that is your positive value, and from x-axis to the negative, it is orange. Okay, that is negative value. So a negative value of D means the fruit fell D units to the right, to the tree's left, and a positive value of D means it falls D units to the tree's right. Okay, now let's see some other points here. So given the value of D for M apples and N oranges, determine how many apples and oranges will fall on Sam's house. So you'll be given a D, like distances from the tree for each apple and each oranges. So you need to find out how many apple and oranges are falling to the Sam's house. Okay, so will fall on the Sam's house, that is in the inclusive range of S and T. So remember guys, so you may found like, okay, if apple is falling exactly at point S and exactly at point T, it may not be included. Okay, but it's not like that. It is clearly mentioning inclusive of range S and T. So point S and T is also inclusive. Let's see the example. For example, Sam's house between S7, okay, and T equal to 10. The apple tree is located A equal to 4 and the orange equal to B 12. Okay, RM equal to 3 apples and N equal to 3 oranges. So 3 oranges and 3 apples have been given. Now apples has fall, 3 apples have been fallen from the tree and their respective distances are 2, 3 and -4. Okay, so unit distance from A and oranges similarly 3, -2 and -4 unit distance. Adding each apple distance to the position of the tree. So now let's say some apple is falling here. Okay, so its distance from A will be, let me just highlight that part. Okay, so we are talking about this particular distance. Okay, that is D, and for orange it will be from here to here. Okay, so that is what you need to calculate it. Okay, so now what they are doing after we got the point, they are just adding from the distances. So apple A is located at what? Point A is 4. So you add 4 in all the points or all the distances, whatever we have given. So 2, 3, 4, right? So 4 plus 2, 4 plus 3, and 4 plus minus 4. That is 6, 7, and 0. So similarly, we do for oranges also, like 12 plus 3. Why 12? Because B is located at 12. That is orange tree. This one. Okay, so you need to add 12 plus 3, that is this point, 12 minus 2, then 12 minus 4. So we got 15, 10, 8. Now how to, based on this distances, whatever we got finally, how to tell whether fruit like apple or orange have been fallen to Sam's house. So of course, S is at 7 point and T is 10 point, means 7 to 10, including 7 and 10, that is the Sam points or Sam's house. So whenever you got the distance, you need to see whether the given distance is less than or equal to S or greater than or equal to S and less than or equal to 2, less than or equal to T. Then only we can say these many apple have been or these many oranges have been fallen to Sam's house. Okay, so you need to find out how many oranges and apple have been fallen to Sam's house. That is the final output. So it has given the example also. Maybe you can take a look, but I think you got the overall idea of what we need to calculate. So let's go back to the programming and do the program. So if you see here, they have already given some program stuff. So that is nothing but they have already filled all the distances in the if statement. Okay, so like first multiple input. So of course you are getting the multiple inputs, right? So 7, 11 is nothing but your point from for what is it, apple tree, and 11 is nothing but a point for D. Okay, so 5 and 15 similarly in the distance, similar other distance, and 5 minus 6, this is your input. Because you can see here input is nothing but the first line contains two space separate integers denoting the respective values of S and C, that is your Sam's house location S and T. Okay, the second line contains the two space separate integers denoting the respective values of A and B, that is a location of tree and location of orange tree and apple tree. The third line contains two separated integers denoting the respective values of M and N. So total how many apple and how many oranges have been fallen. Okay. Now the fourth line contains M space separated integer denoting the respective distances that each apple falls from point A, and the fifth line contains N separated integer for orange. It has fallen from point B. Okay. So this is your S and T, this is your A and B, and 3, 2 is nothing but, let me just recap, M and N. So how many oranges and apple? Okay, so next will be total M apple on and N oranges. Okay, so this is what you need to understand this particular part very clearly, how the M and N are there. So same thing they have already given. So maybe in some programming challenge, what they do, they will not provide this. You need to read the input from the user. So exactly these many lines you need to write. But here they have already simplified the program. They have already calculated it. Okay. So after calculating all the points, they are passing this to the function count apple and oranges by providing all the details S, T, A, B, number of apple, number of oranges. All you need to do is just complete the function. Okay, so before writing the function, let me just go back to the picture. So all you need to do is just calculate the distance of apple, distance of oranges, and see whether they are greater than equal to S and less than equal to T. That's all. If those many points are there, then you just increment the counter. Okay. So let's get to this. So apple, right? Okay, so what I will do, a new. So apple is already having all the distance, right? So I'm going to add another distance equal to, I'll use list computation for n in apples, add n plus. So what is the distance? So distance is SNT, what is A plus N. Okay, so whatever distances they have given, exact distance from their respectivity, that is, if you are calculating for apple, the distance has to be added from A to the given distance of apple. Okay, so A is my apple distance, or apple at point where apple tree is located, and N is nothing but respective distances for apple from the tree. Okay, so total distance will be A plus N. Similarly, I'll use, what is happening, yeah, B underscore mu equal to, I'll use same thing here. So this will be oranges, not apples. Okay, now this will be distance of from B. So all the distances from the tree, orange tree, it has to be at what distance it has fallen, and addition to the point at orange tree is located at point B. Okay, now we got A new and B new. Now what you need to do is you need to count whether A new, that is the new point, is really falling within this point S and T. So every point of A new should be greater than or equal to S and less than or equal to T. Then only we can say it has fallen to the Sam's house. Okay, so what I'll do, I'll just add, let's say, you guys can write any other meaningful variable name also, right? So I'm just using temp. So so what I'll do, I'll just take each apple. So let's say for new distance in A new, if A new, new distance greater than equal to S and new distance is less than equal to T. So if it is new, if it is like greater than equal to S, and because why I'm using equal to, because they have clearly mentioned inclusive of S and T. Remember guys, this line is very important. If you miss, then your whole test case will fail. Okay, so new D is nothing but greater than equal to S, and it should be less than equal to T. Then only we can say that apple has been fallen to Sam's house. Okay, so if this is true, then I'm just going to use A. Just keep incrementing one. So I'll keep adding, I'll just put one, otherwise it is zero only, right? Or nothing has been done. So I'll get list of all ones wherever that condition is true. Okay, so this is for apple. Similarly, I'll use B temp, maybe I'll use total apple, total B, that is orange. Okay, so one for new D, in I'll use B new. Okay, so anyway, this variable could be same also, that's not a problem because it is getting initialized, right? So put one wherever this condition is meeting. Okay, so now we have total A, total orange. Now what we are really, and then what we have to put? Output should be print two integers and two different lines. The first integer, the number of apples to that fall on Sam's house. The second integer, the number of oranges that fall on Sam's house. Okay, so all I can do, print sum of total A. So this will be summation of all the apples that has been fallen to Sam's house, and this will be sum of all the total, because this sum, why? Because I'm getting list of all the ones, and here also list of all the ones. Okay, so let's run the test and see. We are just printing, we are not returning it. Okay, let's run and see what is happening. Okay, so we are getting 1 to 1. Yeah, it looks like this is fine. And now I'm going to submit the code. Let's see it passes all the test cases or not. Wow, it has passed in one iteration. Okay, that's good. So you see here, for this particular input, it is giving 1 and 1, right? Expected output also. And all the test cases, they might have different kind of inputs. And that's what it is running here. Okay, you can clearly check how many outputs have been there. At least for a different test case, it is showing the output, right? What is their input and what is their output. Okay, and we are getting same output, that is expected output. That's why the test case has been shown as green, means it is passed. Okay, they have total 11 test case, all good. For some input, for some test case they show input output, that's good. So you guys can evaluate your results. Okay guys, so that's all for this problem. So those who are not very much familiar with this list comprehension, I think you guys can go to my list comprehension and dictionary comprehension videos and just understand how it is working. In case you are not going to do that, then what you can do is, let me add another solution. Okay, in case you are interested, so I can run same thing using for loop also. Okay, so for, let's say, a in a new, if a is greater than equal to s and a is less than equal to t, this can also be done. Okay, so I'll use total a equal to 0 and total b or total orange equal to 0. Okay, so if this condition meets, then what I have to do, total a plus equal to 1. Okay, similarly you can use it for total orange also. B in B new, you can use O new also, that's fine. I have written this, so that's okay. So B, same kind of condition. So total O plus 1. Let's see if this is also working or not. So just to optimize, I have used what is that? Something it is not iterable. A new, B new, okay. Total A plus. When I use this, then this sum is not required, because earlier we were getting list comprehension of all the list, right? All ones. Now let me just comment it and remove sum. Okay. I hope it will work now. Okay, one test is passed. Let's submit the code. Yes, all great. So everything looks fine. So you have two options. So those who are very new to programming, right, I think they can go ahead with this for loop, and those who are expert now, they can, or they want to optimize the code further, then I think this is better. See how many lines of code you have saved. The complete for loop you have written in 2 lines just, and here you have almost 3 plus 3, total 6 lines of code converted to single line. Okay guys, so that's all for today. We'll see you in next video with new challenges. Okay, thank you, bye bye.